Okay, advent of code day 4. A giant squid wants to play bingo with us. I read through it. That's all I've done. So we're going to need to pass this input and implement a bingo solver. And there are some complexities to this input actually that are worth considering. But let's start by passing it. It's always the most important part. Well, we've got a scaffold day 4. Plus our day 4 here. Let's write a test so that we can check our parsing works. Let input equals raw string that, and then we trim the input, the extraneous characters from the start and the end. And then we say assert task, pass task 1, input, and then, you know, task is as task is right now. Okay, so our parser, oh boy. Oh, and then let's derive debug on things. So realistically, we're going to model every number as a U32 for simplicity, which means we have a sequence is going to be a vector of numbers. Then boards is going to be a vector of use nd array 2 of U32s. So that is what we need to get to. Get there, we are also going to need array 1. In fact, let's pull up the nd array docs for Rust, not Python. And the way I've done this in past ones is to build out the a vector and then reshape it. I think if I look at array base and I look at like reshape, yeah, transform the array into a new shape. Any shape with the same number of elements is accepted. Or I guess like from vec. Create a one-dimensional array from a vector and then resize. Okay, sure. And now are bingo boards also 5x5? Is that like a constant? That is a constant. Okay, good. I'm gonna name that just bingo size for the sake of argument. Const bingo size is gonna be 5. Okay. Cool. Right, so our parser. So the first thing we need to pass is our sequence. So our sequence is nice and easy. We say let sequence is equal to separated list. Imports in here. The separator is going to be a comma. And the things are going to be U32s. So that gives us our parser quite nicely. Then the next thing we need is we need to do okay, so really what we want to do is we also want to remove the new line. So I guess what we need to say is we need to say gap is equal to tuple or well, there's a new way I can phrase this actually that I might use, that I quite like, having been playing around with normal a bit more line ending. So I think in theory, if we bring in nom parser, then we can say line ending, then line ending, and that should exist. Nom rest. Version parser it's and. So line ending and line ending is our gap. Okay. So here we could, yeah. So then we need to say that then we have a separated list of these. So we need to pass a single one of these. Really, I want to pass it as like a flat vector. But I guess what we do is we say that it is I'm gonna bring in like white space 1. Hold on. Space. One or more spaces. Okay, we can work with that. Yeah, okay, sure. So we have space 1. So we can say that our num gap is equal, our bingo sep is equal to alt, which we need to bring in from, you know what? No, we can use the new style. We can say space 1 or line ending. Okay, I'm going to try and use this new style a bit more. It's kind of fancy. I don't know how I feel about it, but I think it might be a bit easier to read. Okay, and so then we need to say that a let bingo is equal to a separated list of bingo sep u32. And we say bingos, or I guess boards, and then this is board. Boards is a separated list of gap and board. Separated list 1. Okay, and then we can say let pass equals map. We need to bring in combinator map. So we would like to map from sequence there and gap and boards into, and so then we have a tuple with a tuple inside it with, let's just see what type this is, I guess. If we say past input sequence is A, that's going to give us like a type error. Boards is just like an empty vector. And then if I say pass input, this should give us a nice type error. Yeah, okay. So now we can see the structure that we have here. So we have a tuple with a tuple on the left-hand side. Okay, so what we have is we have a tuple on the left-hand side. On the right-hand side, we have boards. On the left-hand side, inside this tuple, our right element is the separator we don't care about, and our left element is the sequence. And so now we have sequence, and we have boards, kind of. It should now complain about boards, because we're a vec of u32. So what we need to do is board needs to be mapped, and board needs to do array1 from vec board. From vec is only implemented for array1, right? Yes. But then we can do reshape, and we can reshape it to be board size. It's ix2 board size, I think. Bingo size is what I called it. Owned wrapper. Okay, let's figure out what reshape needs to take. Reshape needs you to pass in E, where E is an into dimension. Oh, okay. It's just a tuple or an array. Okay. Where each element is an ix, and ix is just a usize. So okay, so if I just say, even just get rid of the ix2 and just say bingo size. Owned wrapper data shared is not implemented. What needs to be data shared? We want into shape, not reshape. Okay, that's fine. There we go. Okay, and now it doesn't like that it's a result, so let's bring in map results. Do a map result here. Oh, okay, and we're using gap twice, which means that gap has to be wrapped up like that. I guess maybe I need to put some parentheses around this whole thing. Yeah. No? Oh, because it's an abstract parser, I have to say .parse, not call it like a function. Okay. So technically this should be parser.parse using the new style of stuff. Okay, I don't hate that as a parser. Let's see if it works. In here, let's just debug our input. Probably the easiest way to find out, and run this test. My hope is that we have... Okay, not what I wanted to see there. Unwrap error input is all of this nonsense. What called that unwrap? That unwrap was called in assert task. Where, what triggered it though? Code map res, our reshape failed. Interesting. What's in the board at this point? That might be where it goes wrong. Only the first line. Okay. Peculiar. Is it because it goes a line ending and then a space? Is a line ending and a space. Okay. So it's actually line ending and space 0? Ugh, okay. It's fine. We can work with that. Apparently we can't work with that. What's the error? Show me the error. Right. Reason is okay. Well, it's a bit weird that that doesn't work. If I say ooh, okay. What is that error? Okay. Really doesn't like that. It's because space 0 doesn't have a known length. That's why it hates it, but it does because we know we need a line ending to come after it is the thing. I would like to be able to interpret new line space. Just any white space. I guess I'm just gonna have to build my own little spaces, tabs, character. Okay, multi-space 1 is what I want. I think I want multi-space 1, and then I don't need to specify bingo sep. I can just specify multi-space 1. How does this pass now? Correctly? No. Still doesn't like it. What is the state of board in this one then? Is it still stumbling on Ooh, interesting. Oh, you know why? Because it's reading past the 19, isn't it? Yep, it reads past this 19 and into the next 3. Reading all the way down to the 7. Okay, we're going to have to write a custom separated parser here, so we'll call this board gap. Board gap is going to be equal to yes, it's going to be equal to 1 of how is this used? 1 of. Okay, I see. It's 1 of new line or space. That is our gap. But it is not simply 1 of them. It is the not satisfy what board gap now. We no longer require multi-space. Okay, so you are 1 of space or new line, or carriage return or tab. Let's simply allow white space. But you're not just 1 of that. You are many 1 of them. Many 1. In multi, that is. Multi many 1. And that will get you a vector of those, which is going to be discarded because it is a board gap. Oh, but this is still going to read multiple new lines. So our separator parser fails if them needs to pass, because this is going to have the exact same issue, I believe. Of it, you know, this being overtaking. Does not believe in 1 of. This should be here. 1 of. I guess that's what was accidentally removed. Same error? Same error. Okay. That's fine. So we need to read spaces. It is exactly 1 or 2 spaces, and then either a new line or a new line into space. We can do that. So it is either... Well, you know what? Let's just be awful with this. Let's just take in bytes complete tag. And let's simply say that it is either tag space or tag space space or tag, let's call that space 1. It is either space 1 or it is line end, or it is line end space 1. That's the way to do it. Okay. Or it is line ending. But first, let's actually be over aggressive. Let's say it's line ending, then and space 1, or it is space 1, or it is line ending. It really doesn't like that. Very aggressively, like filling my terminal does not like that. I find that so odd. Is it resolving the wrong OR? That is parser OR. Okay, let's group things. Let's say it's line ending and space 1. Or space 1 or line ending. Is that better? That is somewhat better. Now I might have an understandable error. I'm going to use alt. I know how alt works. I'll worry about learning new parsers later and how to make them work with syntax. It is either line ending and space 1, or it is space 1, or it is line ending. Those are the acceptable. And it doesn't like that. That's so confusing. Rate bound. Slice is not fired by line ending. Is it because line ending can mean new line or carriage return new line? Is that why this is failing? I mean, okay, we can do this the other way. I don't like doing this. So we'll say let row is equal to separated list of space 1 U32. And then we'll say let we'll remove the board. We'll you know, let's just comment this out for now. So board is a separated list of spaces and then U32s. Why does it not like this separated list one now? It'll figure it out. It's because we're not using it. And then board is equal. Okay, but a row could begin with a space. Separated list expects passes the separator between list elements. Okay, so let's say space 0 then separated list is what a row is. Space 0 and, of course. Okay, so there's our row. That gives us a single row. And then we need to do rows. Rows is equal to separated list of line ending row. And then board is map res rows a vector of vectors. Oh, it's a vector of space 0 and then vectors. That's unpleasant. Yeah. Okay, I'll have to handle that. We can say I into iter map I flat map, of course. Okay, and now we can say array. What in array implements from iter? From iter is only implemented for 1. Okay, so array 1 from iter into shape bingo size. So that should be the board parser, and now the rest of this should be the same. Don't use this, we don't use this, we don't use this, and hopefully now if I run the test we get test passes okay. Right. debug our input. That means that our parser didn't fail, but I would still like to see that it passed. It did what we expected it to do. That looks correct to me. So we have a big sequence. Boards is 3 boards. Perfect. Perfect, okay. Right. So parsing done in 25 minutes. Slow for me. Let's fix that. So now what we need to do is we need to say so really each board needs to not just be a board but also have a Boolean mask. So let's create our own structure called struct bingo board, where board is an array 2 of u32 and then marked is an array 2 of bool. That seems like the best way to do it to me. And then in here, bingo board. And then boards we can simply change to be bingo board. And then it is board is this, and then marked is, and this needs a question mark and an OK. And then marked is an array 2 from element bingo size, and false. Oh, of course, because question mark doesn't necessitate. Okay, so we'll say match this nonsense here. OK board is then a bingo board. Actually, we can do this with a map much more elegantly. So we'll say this nonsense here, map board into a bingo board. Perfect. So now we have bingo board and we can implement some logic on that. So what logic do we want to implement? We want to implement a mark function that takes a thing and marks it on self. Yes. So how does this work? This is going to say self.board. I guess we want to find indexes, so we want to do enumerate. I think enumerate. So we want to say board, or not enumerate, unless we have a custom enumerate implementation here. No. Indexed iter, that's what we want. For whatever this gives us. Okay, so this gives us our x, y, our position and our value. We want to say if value is equal to n, then we say self.marked index mute at pos is equal to true. So that's the mark step. It's nice and simple, I think. Or an asterisk there. So that's the mark step. And so then that's marks a value. Then we need to check if, I guess mark can tell us if we win, because it has fewer things to check. It needs to only check the row and only check the column. So we'll say pos at AB, or oh sorry, it's AB at pos should do this, right? No? Pos, is it this pos at IJ? Yes. So this gives us both the overall position and it gives us the independent I and the independent J. Okay. So then what we need to do is after we mark it, we need to say check the horizontal and the vertical to see if we win. We're going to we're going to return an option of the score. Okay, so down here we'll say none. So if we slice, so we say self.board.slicing. It's just .slice, okay. But we need to import the S macro. So we'll grab the S macro from up here. We don't need index yet. Self.board.slice, and we're going to slice, and we want to look at all of the first axis and only only J in the second axis. That is legal syntax. Okay, perfect. So this is the J set, and then we also have the I set. So we'll look at marked first. Self.marked and self.marked. Slice, and then this one here will be I. Let's do I before J. Okay. So then if I set dot iter dot all. So if everything is marked, then we need to say return some board slice, same slice, all of them, and it is iter.map, or I suppose just iter.sum would work here. And we can do the same thing here and say if jset return the sum of the J index. And that should be the entire logic that we need for that. Okay, so then for puzzle number 1, we need to return, well, we also need the number that was just called. Well, that's fine because that's n. Okay, so what we need to do in here is we need to say for value in input.sequence. So that gives us each successive element from input sequence. We need to say for board in input.boards, iter mute. We need to say board mark value, but we say if let sum win equal board mark of our value, then return okay win times by value. Okay, and so this for this one here gives us 4, 5, 12, and my hope is that this will unit, of course, because we need to return a U32, and then down here we need to say error is this is error no winner found into. Run this test. Now I'm hoping this passes. Okay, well we no longer need to debug this, so we'll remove our debug implementation. Run our test again. Okay. Cannot borrow boards as mutable because it's behind an and reference. So it is, so it is. That's fine. We'll operate on a clone of it. So I'll just derive clone. because we need mutability, and the setup here does not provide mutability. So it needs to be persistent for every value, so I'll say let boards is input.boards.clone, but is mutable. And here we'll say boards iter mute. Failed. We got a different number. Okay, let's have a look at what our win value was and what our board value was. Well, actually, hold on. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. In this case, the sum is 188. Then multiply that by the number that was just called. Okay, sure, whatever. Let's just change this then. So the score is the unmarked score. Whereas here, I'm returning it as if it is the sum of the row that was marked. Okay, I actually need to do more complex logic here. So rather than just looking... So we do need to look at these, but if I set iter, then... Okay, we compute... Well, we need a compute score method. Compute score will tell us the value of a current board. And the score of a current board is equal to for position value in self.marked.indexed iter.filter pos where value is true. So this is going to give us the positions of all the positions of all of the marked cells. Where we want unmarked, all unmarked. So we want the to be not the value. So we actually want to say this here, filter to that, and then map to pos, and say self.board.index pos sum. Indexing here is a safe thing to do, so let's just import the index operation. Let's use get and use filter map, and then in here let's also use get mute, and let's say if let sum v equals this, v is true. There we go. Now we're no longer risking panicking. It wouldn't panic anyway because of how we've set this up, but we're no longer risking it. So this is actually... Compute score is now working in theory. So now in here we simply return... So if this or this, if either of those is the case, then return self.compute score. And we move the JSet to be at the top there. Sum compute score. Now this should give us the right answer. And it does, lovely. With a win of 188 and a value of 24. That is what they are doing in there. So we can remove our debugs because our code works. And with that working, in theory, we can do our first true run. $85.80 for my one, and that's correct. Okay, part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards the giant squid could play at once, so rather than waste time counting its arm, it's safe to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. Okay, and it has 1924. So let's plug in task 2 to start with. So task 2, we are trying to score a pathetic score of 1924. Okay, and so for task 2, we're going to say very similarly. In here, we'll just say no loser found, even though that makes no sense at all. So we'll say value. We want the final board to win. Okay, so we'll say let last win is equal to. Oh, okay. We need to know a way. We need a way to track if a board has won though. So we'll say let mute board has won is equal to boards dot iter dot map to false dot collect into a vector. So now we have a vector where the elements are false if the board has not won. So now we say for value in each board, we say for board in boards. We could simply retain. We could use retain. Let's use retain. This is vector retain. Yes. Sure. So we'll say, rather than doing this, we'll say, comment this for now. Boards.retain board, and we will know retains only this board specified by a predicate. We don't have, why do we not have mutable access? Is there a retain mute? Okay. That is annoying. I was hoping that we could use this as like a filter reduction. We can do that. We can say boards is equal to boards dot iter mute. Well, I guess dot into iter map board. Okay, so now in here, this is filter map actually. We only want to return boards that are still playing. And if it's unless it's the last board, in which case we may want to universally return. But that's fine, we can call compute score on it after. So that's okay. If there's only one board left, and if the board wins, okay. I think we should go back to the idea I had where I would simply keep a separate list of which boards have won. So, yes. Okay, so now what we'll do is every board we will say, for each board, so first thing we need to do is we need to check if a board has won. So we'll say if, or no, we'll have to check if there's only one board remaining. We can do that. We'll do that in okay, so if somewhere boards.itermute.enumerate board. So we say if board has one dot get I is equal to some false, then we're going to mark the board. Okay. And we don't care about the win. Oh, no, we do care about the win, but we only care... Okay, so we'll say if... we can get this from board has one. We can say that tells us our total boards won. We actually want the opposite. We want total boards boards remaining. And then only if our boards remaining is, so if boards remaining is 1, board has 1 dot get mute I. So there we'll set it, and then we'll say board remaining, if boards remaining is 1, which won't be updated by this because that was got before we even checked, then return some self board dot compute score. Oh, return OK board compute score times by a win times by value. This is a U32. Passed. Beautiful. I'm not a huge fan of this double vector approach, but I think it certainly gets the job done, and it gets it done quicker than I did yesterday's. So, perfect. Well, that's today's Advent of Code. I wonder. I suppose we could track has one in here, but I think that's excessively complex, so let's not. I think we'll leave this here. Thank you very much for watching.